Okay, so you're going to do the second set of notes. Notes 38, mass to mass. This unit is really going to be pretty short because we did 1-steppers yesterday. This is 2 and 3 steps today. And then we just practice those this week. Next week, you'll do one more thing that goes into this unit. That's really it. So it's like we realize that these kind of problems take a while to get and practice. So that's really all that's in this unit. It's a good and bad thing. So it's a good thing because there's not a lot to it. So it's going to be fairly short. We'll be done with it before spring break. The only reason that it would be a negative is because there isn't going to be like all these different kinds of stuff that you could possibly get right on the test if you can't get this. It's like, no, this is it. This is what's on it, is these kind of calculations. And then we will get to move on past moles after this. All right. So here we go. Stoichiometry, mass to mass. So yesterday was all 1-step problems because they were mole to mole. When mass is brought in at all in these problems, it's going to be a 2 or 3 step. So if I'm going from grams to mole or moles to grams, in this case, in stoichiometry, now before moles was in the problem with 1 step, but now if it is grams to mole, this is a 2 step. So if I'm going from mole to gram or gram to mole, vice versa, this is a 2-step problem. And in a second, when we get down to our second or third problem, am I lying? I don't think so. Well, let's just figure it out. So this is really the only way to solve these problems you can see is from the notes is just by doing it. You just have to start. You have to use all the conversion factors that we have used so far in the last mole unit and the conversion factors from yesterday, and put them all together into one. And there's really no better way other than just start. Just take what's given and write it down. So I'm going to start with 250 grams. And remember the substance, because we're going from oxygen to carbon dioxide. Since I'm changing substances, I have to write it so I remember where to put the right one to cancel the right substance. So I have 250 grams of oxygen, which in this case is O2, like that. I'm going to set up my first fraction. No, I'm not going to be done, so I'm not going to put the equal sign. Now, I have grams to start, so that means grams of O2 is going to go on the bottom. Now, from our previous unit in moles, all we had was we had mole to grams, or vice versa, grams to mole. We also had mole to particle, so remember that was atom or formula unit, over the atom, or molecule, right? Okay, so those were our old types of conversion factors, and one always went with mole, and grams was molar mass, meaning you add it up on the periodic table of whatever we're dealing with, and the atom, formula, or molecule always got the 6.02 times 10 to the 23rd. I'm gonna rewrite that so it's a little easier to see. So you have the mole over 6.02 times 10 to the 23rd, and that was either atom, formula unit, or molecule. Yeah, it always writes a lot worse. The closer I get to the edge, it looks worse and worse on these markers. All right, so those were our old conversion factors, and our new conversion factors are using the numbers that are in front. So right now, my question is asking for go to oxygen from carbon dioxide. So I don't need this one, it didn't mention it. And I don't need water because it didn't mention it. So I'm focusing on these two. So my conversion factors for these two is I have 5 moles of O2, so see the 5's in front of it, for every 4 moles, because there's a 4 in front of it, of CO2. So those are all my possibles. Now I might have to flip them up or down, but I have these 3 conversion factors, and that is it. You just have to put them in the right spot to cancel the unit that you want to cancel. So right now, I have grams. Okay, so I'm going to look at my choices. The only one I have up here that we've ever used with grams was grams to a mole. So I know it's going to be a mole up there. And it's always a mole of the same substance. So this is mole of O2. So remember, the substance is really important. So in all of these, their substances match. The mole to atoms and the moles to grams, their substances always match. Our new conversion factor here is when it starts to swap substances. Our old units never swap substances. Okay, now what with mole was always a 1. What with grams is molar mass. Well, molar mass of what? O2. That's why we had to write O2, so I would know what to go do. So it's the molar mass of oxygen. So oxygen on the periodic table is 16, but there's 2 of them, so times 2. That molar mass would be 32. So that is my molar mass, which goes here, 32 grams. All right, now if I stopped right here, grams would cancel, and it would leave you with moles of O2. But they didn't ask me for moles of O2, they asked for moles of carbon dioxide. So I'm not there yet. So I'm going to multiply by another line. Now this is my new top. So it's going to be my new bottom, because I wanted to cancel moles of O2. So here is where we got to kind of think of what to do. Basically, your goal is to get to carbon dioxide. So I'm looking at my choices. I've already used this choice. I don't need to do that choice, but I don't need to go atoms of oxygen. I don't really care about oxygen. I'm trying to get carbon dioxide. This one could get me to carbon dioxide. So if I go from moles of O2, I can get to moles of CO2. So that's at least getting me to CO2. And actually, that's what they asked me for. They asked me for moles of O2. I mean, moles of CO2, so I will be done. Yeah, this is a 2-step problem. I have it set up. Now I know it's a 2-stepper because I'm getting the unit they asked me for to get at the top at the end. So I'm going to go ahead and put my equal sign because I know it's going to be the end as soon as I solve it. Move this up. Okay, like that. Now, what numbers go with these? Remember, when it's a mole to mole from yesterday, it's our new conversion factor. We're going from moles of CO2 to moles of O2, so moles of different substances. And it's just the numbers that are in front of them in a balanced equation. So CO2 has a 4 and moles of O2 has a 5. At this point, moles of O2 would cancel. You're left with moles of CO2, which is what they asked you for, moles of CO2. So they asked you for in the problem. So all I gotta do is solve this. So how is this going to go in the calculator? Is you're always, or this is technically on top, is multiply the top numbers. So I'm gonna have 250 times 1 times 4. Okay, multiply the top numbers. 250 times 1 times 4. Hit enter. Now I have to divide by the things in the bottom. So you have a choice here. Technically, there's 2 things on the bottom, and they are being multiplied with each other. So I could hit divide, parentheses, 32 times 5, close parentheses. Or I could use that hit divide and divide by 32, hit enter. So that's my first one is 32. And then I can hit divide again and divide by 5. So put it in sections. And I get 6.25. We'll put it in the right spot. 6.25 moles of CO2. And there we go. That's your answer. 2-step problem. Done. Scroll down. Yeah, so we got one more 2-stepper, and then I think we have a 3-step problem. Okay, so how many grams of oxygen would be needed to produce 10 moles of water? So I'm looking at my question here. I'm seeing I'm going for moles of water. So I have this. I have 10.0 moles of this one, water. And I want to get to grams of oxygen. So I want to get to grams of, let me put that. Let me put a question mark. Grams, question mark on oxygen. So I'm not really even caring about these other 2. They're not a part of my question, so I'm going to ignore them. Again, the mole to grams is going to be a 2-step problem. The last one is a gram to gram, and that's going to be a 3-step. But so we're still on 2-step right now. Okay, so like always, I'm going to start with what's given. 10 moles of H2O, and the substance is important, so you write it down. Fine. Start looking all squiggly. Now I know for sure this is a 2-step problem. So I'm going to go ahead and set it up as 1. Whatever unit you are starting with is the unit that's going to go on the bottom next. So I'm going to go ahead and do that. Moles of H2O. All right. Now, my goal is to get to grams of oxygen. So when I'm trying to figure out what I want to do, I don't need to go, remember I have moles, I can go from moles of H2O to grams of H2O. That's our old conversion factor. I can go from moles of H2O to atoms, will actually be molecules, because atoms are for single elements, but molecules of H2O. And I can go from moles of H2O to anything in my balanced equation. So I can go to O2, which is what they actually asked me to do. I can go from moles of H2O to moles of O2. So I'm looking at my three choices here. The one that's going to get me closer to my goal, which is getting to oxygen, is this one. I'm going to go here. Now, the numbers that went with your mole to mole, your mole of H2O to mole of O2, was just your numbers that were in front of them. So a 2 would go with the H2O, and a 5 would go with the O2. So down here is H2O, so it gets the 2, and O2 gets the 5. Again, I'm just getting them from the numbers up here. So anytime you're going from a mole of one thing to a mole of a different thing, so you're switching substances, and you just use the numbers in front of them on their balanced equation. So at this point, moles of O2, of H2O would cancel. I have moles of O2, but they asked me for grams of O2, so I'm not done. This is my new top, so it will be my new bottom, moles of O2. Now I'm going to look at my three choices again, and the thing that's going to get me to grams is this guy, right? So moles of H2O, or now it's O2, it was H2O, but now it's O2, and I can go to grams of O2. Now, if you look above to what we'd already written, what went with mole was always a 1 in our previous life of our mole unit. Now it's mole to mole, like we're learning over here, they are different numbers, not 1. But if it's mole is something else, like mole to grams, mole to atoms, mole to formula units, then the mole just gets a 1. Now the grams is molar mass. So remember, it's molar mass of this guy, O2, which happens to be the same one we found molar mass for in the previous problem. So 16 times 2 is 32. That's the mass on the periodic table. So 32 grams. All right, at this point, moles of O2 cancels, grams of O2 is what I'm left with, and grams of O2 is what they asked me to get to. I'm going to erase this just for room. Okay, so they asked me to get to grams of O2. I'm there. I just got to solve it. So how I put this in the calculator? Again, you multiply the tops, divide by the bottom. So it's going to end up being 10 times 5 times 32. I'm going to get an answer, and then I'm going to hit divide by 2, and then divide by 1, because that's what it is. Divide by 2, divide by 1. That's what I'm putting in the calculator. So 10 times 5 times 32, hit enter. Divide by 2, and then it says divide by 1, but I don't really have to do that. It's the same number. So the answer is 800 on the dot, actually, grams of O2. There we go. All right, now we have one last long problem, and then we will just be doing things to practice this throughout the week. Okay, so same deal. We're going to start with what's given. I'm going to put things in the right spots. So I'm given 75 grams of carbon dioxide. This one, 75 grams of carbon dioxide. They want me to get to grams of acetylene gas. Now, I don't expect you to know exactly what acetylene gas is, but you know that this is oxygen. You know that this is water, H2O. So you know those aren't acetylene gas. So we're not using those. The one that we don't know, C2H2, that's got to be acetylene gas. So it's just process of elimination if they give you a gas phrase like that. So I want to get to grams of this. So when it's a gram to gram problem like this, a gram to gram or vice versa, in stoichiometry, it's going to be 3 steps. So I'm going to write down what was given, 75 grams of CO2, and I'm going to multiply by 3 steps. Okay, now let's set up. I'm going to start plugging things in. So I got grams here, so grams is going to go on the bottom, grams of CO2. In our previous examples, grams was always 2 a mole. In our whole last unit, it was always a mole, and mole always got 1. The grams is molar mass. Remember, it's molar mass in the periodic table. That's what grams is. It's a mass, so I'm going to add it up. Carbon on the periodic table is 12.01 plus oxygen, but oxygen times 2. Why, smart board? This looks like a 12.01 plus 16 plus 16, because that is 2 oxygens. All right, so I add those up. It'll be 32. It'll be 42, 44, 44.01. So 44.01. There we go. Molar mass of carbon dioxide. Now, at this point, and this is still carbon dioxide up here, remember? So I didn't change substances. We never changed substances in our previous unit. It was just grams to mole of the same substance. So I have grams of CO2 here, and they cancel. And now I have moles of CO2 up top. Well, I don't even want CO2. I want acetylene gas, so I'm definitely not done. So I'm going to put my mole of, I don't know why I changed color. I'll try again. I usually just write the markouts. So I have mole of CO2 here now, because it was my new top, so now it's my new bottom, so I want it to cancel. In our previous 2 examples, my whole goal is to get to acetylene gas. So I want to get there as fast as I can. The conversion factor for me to switch substances is a mole of CO2 to a mole of acetylene gas. Well, I already have mole of CO2, so I can do a mole of C2H2, and that will help me switch substances. So here's my switch to a different substance. The numbers that went with our new conversion factor here, this is the new one. This is the new one for this unit for stoichiometry, are the numbers that are in front of them. So 2 is in front of C2H2, and the number that's in front of CO2 is 4. So I have 2 and 4. So at this point, moles of CO2 cancels, and I'm left with mole of C2H2, mole of acetylene gas. But they don't want mole, they want grams. So in our previous 2 problems, this is where we would be done, but this time they said to go 1 step further and tell me how much to weigh out, how much in grams. So I need to get rid of mole of C2H2 now and go to grams of C2H2. Now, just like our previous problem over here, we did moles to grams over here, but it was mole of CO2 to mole of CO2. Now we're mole of C2H2 to grams of C2H2. So we switch substances, but it's the same setup. Mole always gets a 1. And remember, grams was molar mass, but this time it's molar mass of C2H2. So it'll be 12.01 times 2, because carbon is 12.01 times 2. And add that to hydrogen, which would be 1.01, because that's its mass in the periodic table. Hydrogen is 1.01 times 2. So I'm going to add all that up, and that's going to be the molar mass of C2H2. So 12.01 times 2 plus 1.01 times 2. And the answer is 26.04. And that's the molar mass. Okay. So at this point, moles of CO2 cancels. Grams of CO2 is what I left with. Grams of C2H2, I mean. And that's what they asked me for. Acetylene gas is C2H2. So all I have to do is put this in the calculator. Now, we multiply. This is a lot. Like, it's a long problem, but it's still just multiplication and then division. So you're going to multiply 75 times 1 times 2 times 26.04. Put that in the calculator first. 75 times 1 times 2 times 26.04. What about that? 36. 26.04. Okay. Hit enter. Now I need to divide by the things at the bottom. So I'm going to divide by the first one, which is 44. So divide by 44.01. Hit enter. Now I need to divide by the second number. So divide that one by 4. Now you divide by the last one, which is 1. I don't know if I can do that. It's the same answer. So my answer is 22.19 grams of C2H2. That's how much you would have to weigh out. So if I started with 75 grams of CO2, I would end up, no, wait, I'm saying if I produce 75 grams and how much acetylene gas did I use 21.19 grams of acetylene gas to do that. Okay, so what would be important to know about how many moles of chemical to weigh out before the beginning of the reaction? Why would it be important to know how many moles of chemical to weigh out before the reaction? So the point of this, you use these numbers in the balanced equation to know how much to weigh out. I just showed you that if you go from moles to grams, like we did in the first 2 problems, those are moles to grams problems or grams to moles, that tells you I need 5 moles of O2. Well, how do I know how much 5 moles is? Well, 1 mole in the periodic table is just the molar mass. So 16 plus 16, because that's what oxygen's mass is, 16 plus 16. If I need 5 of them, 5 moles, well, I just take 16 times 5. That's how much mass of oxygen I would need for this reaction to occur and have no leftovers. So I want to weigh out the right amount before I do a reaction because I want to make as much product as possible. Like if that's my goal, I want to make as much product as possible. And if I don't put in the right amount in the beginning, then I'm not going to make the right amount of product in the end. So I make the most product as possible. I don't want to have leftovers. Don't want leftover products. So let's say if I put in enough acetylene gas, but I didn't put enough oxygen in, well, then I'm going to have acetylene gas leftover. It's not going to fully react. I'm going to have leftovers, and I'm not going to be able to make as much product. So it's just to measure out the right amount of your substances so that you don't have leftovers, so you make the amount that you want when you're trying to make those products. So this is something they actually do have to calculate for any kind of business that makes any kind of chemical. They're going to put in the right amount of ingredients. And how do they know how much to put in from a chemical reaction? Okay, it tells them. You read it and you do the math, and then you know how much to weigh out. Okay. Done with those notes.